Hey everyone, and welcome to the second video from chapter 14. Now, this video and the next video work pretty much in tandem, so I would highly recommend that you watch them back to back because in this video we're going to be talking about the simple deposit multiplier, and then the next one we're going to build on that with a more realistic deposit multiplier. So, in this video, we're going to talk about first the concept of multiple deposit creation, and we're going to do so through a pretty simple example, and then we are going to derive our simple deposit multiplier. So, if you remember, the aggregate money supply is equal to the monetary base B times the deposit multiplier. So we'll call it deposit multiplier. Uh, and so now that in the first video we established what B is, we're going to move on to deposit multiplier. We're going to do so through this simple example. Let's say that the Fed buys 100 grand of treasuries from Wells Fargo, who is a primary dealer. In doing so, Wells Fargo's assets are going to decrease by $100,000 in securities and increase by $100,000 in reserves. So net no change in their assets. Now, let's assume that Wells Fargo loans out $100,000 by making a checking account for a client and depositing it in it $100,000. So that client in their checking deposit, they have $100,000. And so on the flip side, on the assets for Wells Fargo, their securities are going to decrease by $100,000 because they uh, have to get rid of this treasury bill. Then their reserves go up by $100,000 because they get cash for the treasury bill. Then their loans go up by $100,000 because they loaned out that $100,000 to a client who will inevitably have to pay them back. This means that the Fed's action increased the M1's money supply by $100,000 when we look at this T chart. But let's look more broadly at the economy. That person, they're not going to take out a loan just for nothing. We're going to say that they need $100,000 to remodel a corporate building. So they need to get that $100,000 out. So they're going to put their checkable deposits to zero. They no longer have that $100,000 in their checking account. On the flip side, Wells Fargo is going to have to drop out those $100,000 in reserves. And so Wells Fargo has lost that $100,000 because they gave it to the individual. And then that individual gives it to a contractor that they're going to employ to remodel the building. That contractor then in turn deposits it with PNC Bank. What does that mean? Well, PNC Bank's assets increase by $100,000 in reserves, and they increase by $100,000 in checkable deposits. But PNC Bank is probably not going to just let their money sit when they can make money by loaning those increased assets back out. But let's say that the reserve requirement is 10%. Then that means they can only loan out $90,000 of the initial $100,000 deposited. So the liabilities are going to go up by $100,000. Their reserves are going to go up by 10% of the $100,000 or $10,000, and their loans are going to go up by $900,000. So you still get this balance between assets and liabilities. And so PNC Bank loans it out to an individual who immediately deposits it with SunTrust Bank. Then SunTrust, the same thing happens. Liabilities go up by $90,000. Assets go up by $90,000 in the form of reserves and checkable deposits. And then SunTrust can then loan out as the reserve requirement so they can make an $81,000 loan themselves, which means that the Fed buying a $100,000 treasury bill increased the money supply by $271,000 just in this simple example. This is called the multiple deposit creation process. And so assuming a reserve requirement of 10%, there will be a maximum increase in deposits from a $100,000 treasury purchase of $1 million. And I'm now going to derive how that's possible. So with our simple deposit multiplier that we're going to expand on later on, uh, it's just the ratio of the amount of deposits created by banks to the amount of new reserves. And if you remember, we calculated the change in deposits from the $100,000 T-bill purchase as $100,000, so the initial exchange for the T-bill for cash, and then it went to the contractor who had his money lent out less the deposit requirement, so zero point 0.9 times $100,000. Then it went to SunTrust Bank, who then loaned it out, but they only got $90,000, so zero point 0.9 times 100,000, and they could only loan out 0.9 of that, so they could only loan out $81,000. And this can keep going and going and going on. So we're going to do a little bit of algebra here. We can factor out the $100,000, and then what we end up doing is just getting this factorial on the right side of the multiplication side. So you're going to get 0.09 from here, then you're going to get 0.09 squared from this term, and then it just keeps going and going and going. And we can concisely write this as delta D, so the change in deposits equals 100,000 times from 0 to infinity, 0.09 raised to the n. So note that this is important because this means that on that very first deposit, you get 0.09 to the 0 power, which is equal to 1. Hence, we account for this very first term. Now, if any of you do any sort of advanced economics or statistics, what we're going to do right now is a very useful trick. The rest of you can just sit back and watch. There's a very nifty mathematical rule that says anytime you have a term like this, where a number that is less than 1 is raised to the n power until infinity, you can convert it into 1 minus 1 over 1 minus that original number. And so we're going to employ that here to get the change in the money supply is equal to $100,000 times 1 over 1 minus 0 0.9, which is equal to $100,000 times 10, or $1 million, the number that we had earlier. For the rest of you, this is where we get our definition of the simple deposit multiplier. The simple deposit multiplier is equal to 1 over the required reserves on deposits. So this is the required reserve ratio right here. Therefore, the change in the change in total deposits is equal to the change in reserves over the required reserve ratio. So that is how we're going to get, in this case, a simple deposit multiplier of 10 when the required reserve ratio is 0.1. Now, this simple deposit multiplier has quite a few flaws that we're going to talk about in the next video. But note that right now, that means that since the required reserve ratio is 0, then the change in deposits from any sort of open market operation from the Federal Reserve uh, is is infinity. And obviously that's not actually the case, and so we're going to put some permutations on this formula in the next video, but it does give you a good understanding of where we're coming from with this deposit multiplier derivation.